In this fourth tutorial, I'm going to show you how to create a sliding tray using finger joints. When we first started this, we set up some initial parameters and we need to set up one more. One of the things that you can do, or what happens is, as projects develop, they can get quite complicated in terms of how the parameters relate to each other. So I'm going to show you how you can create new parameters that actually are based off earlier parameters that make certain processes a little bit easier. So to give you an example of what I mean, I'm just going to turn the lid off. I'm going to make a sliding tray that sits in here and fits to this dimension here. Now if I just click on that and you look right down the bottom here, you can see it's 106 millimeters long. The other tool that's really useful for that is the inspect tool, and there's quite a few features in there, but the keyboard shortcut is the letter I, and similarly you can either click on the line that you need or whatever you need, or you can click on some points and it can give you some measurements. So for example, I've got 196 millimeters along there. So let's go and create our new parameter. So what we'll call it inside width. And the expression here is going to be overall width minus 2 times material thickness. So you can see it gets a little bit mathematical there, but you can see we get the same value. The beauty of having this means that, again, if we change the dimensions of the box, the material thickness or overall width or anything like that, this will automatically adjust. All right, so now what I'm going to do, I'm actually going to hide everything because we're going to start again with a new sketch. So create sketch, and this time we're going to go off the front plane. Now when you create a finger joint in the workshop, often that's done with a router, and therefore your finger joints are, like the spacing between the joints is defined by the diameter of the router bit that you're using. So fairly common router bits might be a 6 millimeter router, it might be a 9 millimeter or a 12 millimeter. In this case, what we'll do is I'm going to go with 9 millimeters. So we'll use a 9 millimeter cutter. And generally when you're calculating the depth of the box, it's an odd multiple of 9. So we'll go for an odd multiple of 9. So to do this, there's a few different ways you can do it, but I'm just going to go L for line tool. I'm going to start at the origin and go up, and it doesn't really matter how far we go. Then I'm going to go back, up, up, cross, up, back. So I'm pretty much just creating my overall design right now. But I'm not worrying about, so I'll just press escape. All right, I'll come in a little bit closer now. In fact, that last line I don't need, so I'm going to delete that. So what I want to do is I'm going to put in some dimensions, and you can see at the moment that all of these lines are blue. So that means they're not constrained. There's no rules defining, their existence basically. So I'm going to just put in this first one here, and I'm going to make that 9. Now again, I could put a parameter in and just say, call it router, or finger joint diameter or something like that. And so I could change that as well. So I could do it that way. The other one that I want is this one, and there will be a function here because this depth of the cut is defined by the thickness of the material. So again, we'll use the 12 mil. So we'll use material thickness. So now all we need to do is then just define the rest of these dimensions off these dimensions. So what we can do is we can actually just use a constraint, and we just want to make it equal constraint. So this one here is equal to that one there. This one here is equal to that one there. Okay, and then same again this way. So we've got this one here needs to be equal to that. So that's equal to that. That's equal to that. That's equal to that. And this one is equal to that. Okay. So hopefully you can sort of follow that. The other thing we're going to do, instead of drawing this twice, because obviously we've got to do it at the other end, I'm going to show you another little trick here. So we're going to draw our horizontal line, which is going out this way. Now, before we created that, that parameter, so we're going to use that parameter. So there's my line. So I've just got to define its length. So instead of 70, we're going to call it inside width divided by 2. Now, you might be sort of going, what's he doing that for? And you'll see in a minute. So alpha line again, I'm just going to do another line up here, deliberately make it a different length. But again, I'm just going to make it equal to that. Okay, so basically what we've got is we've got half a piece. So one more line, and this one is now going to be a construction line. And I'm just going to go from here to here. And then I'm going to mirror it. So rather than draw it again, I'm just going to mirror it. And I'm going to, so you can see it's up here. So objects, I'm just going to select everything that I want to mirror, which is everything. I'm going to mirror it around this line here. So I'll select that. There you go. Now you can see we've got it. Go, okay. So you can see now we've got that entire piece. So we'll finish that sketch. So now all we've got to do is extrude it. And we'll go material thickness again. And new component. So you can see it coming up here. So we'll call it tray side. So now we've just got to create the corresponding piece that goes with it. So new sketch, and this time what we're going to do is we're going to actually sketch off kind of this surface here. So we'll come in, and again, this one's going to be a little bit slightly different. So we'll go our line tool. We're going to start up there. So basically now just doing the opposite. Now what we can do, because that's, we can't be exactly clear on what we're seeing there, I'm just going to turn that tray side off so we can see it, and which is good because I can see that I've missed putting a line in there, so I'm just going to do that. And then basically then all I've got to do is the same again, is just use the equal constraint and just make that is equal with that. And then these vertical ones equal. I've over constrained it. There we go. We've got it all right. Now for this one, what we can do now is we'll have our line. We can actually draw our line sort of out from here and get our size right. So we can go L. If we go from that point there, and then we'll go along, and we'll just define that same as we did before. But we've just got to then delete a little bit off it. So inside width divided by 2, we get that number. So what I'll do now is I'm just going to use my modify tool. Now it's not gonna like this, and so what I'll do is I'm just going to now press escape, and then just go another line down here. Doesn't matter the length, And then again, press escape. We'll just use our equal constraint and we'll make that line equal to that line. There we go. So final line, and we'll change that to construction because we'll do the same thing again where we mirror it. So we'll select everything that we need to. And then we'll select our mirror line. Okay, we've got it. Then we'll finish the sketch. So you can see that there. Now we'll turn our tray side back on so you can see which way we're going to extrude that. So we'll extrude it, select it, new component, and we're going, oh, didn't like that. And we're going minus, in this case, minus material thickness. Okay, and you can see that they're now meshing together. So we'll call that tray end. Now there's a few different ways we can complete this, but I'm going to show you a new way. So this is now more of an assembly method. We could mirror this again and just create the other two components, but I'm just going to use this assembly method. So if I select tray end and right click on it, move copy and create copy. And what I'm going to do, I'm just going to move it away from it just so it's not touching it. Go OK. Then I'm going to use an assembly function. So you can see that here. We're going to just do some simple joints. So we've got that one there. So that's keyboard shortcut J. So if I just press J, then I'm going to just kind of select a known point and attach it to a known point. Now, joining things can sometimes get a little bit funky where things can start spinning around and all that sort of thing. It just depends on how you join it. So basically what I'm going to do here is I'm going to look at this corner and try to align it all so that I get the red line going vertically, and then just select it so I've got that line there and that sort of little icon sits in the middle like that. Okay, so I've got that one. Then I'm going to come over here and I want it to look the same. So if I had it sort of, there, it would not join properly, or like that, it wouldn't join properly. So if I got it looking the same like that, there we go. It's joined okay. If it doesn't join properly, just go backwards and have another go until you got it joining properly. So, okay. So I've got that. We can do the same thing again for the tray side. So select it, move copy, make sure we're creating a copy, and again we'll just move it all the way. So we'll go there. I'm just going to zoom that. Fit it back on the screen. J for join, and yeah. So same as before. I'll just come in and get that. This time now I've got that red line going out horizontally. So long as I've got the same thing happening here, that's the main thing. All right, so I select that, then I'll select that, and there we go. What I might try to do, that so it doesn't work properly. So again, J for join, I'll just deliberately try to bugger that up. Yeah, so let's say I go like this where it's looking slightly different. It's not selecting that edge, it's selecting the face, and you can see what it does. So the key is you've got to get whatever joining method you're using, because the other one that you can use, J for join, you can try corners. They can be a little bit troublesome. So see again how I've got them looking the same. That works fine. But if I cancel it, I'll try to mess it up again. So J for join, I'll try the corner. You can see it spins it, but that's because I didn't actually select the corner. I ended up selecting the face. So just have to be careful with that. So J for join, I prefer my edge method. Seems to be less troublesome. Then okay. All right, so we've basically got our tray except for the bottom of the tray. So how about we'll come around and we'll change our view slightly. We'll do another sketch. And we'll go straight off we can come straight off the bottom, or we can just come off the bottom plane here. So we need a half a rectangle, so we don't need a center point rectangle in this case. Just going to fit that on the screen a bit better. And I can go from the origin and I can come out. And I mean, I don't actually need it to snap to here because I can use exactly the same formula that we used before. So for example, I'll just go like that, and then I'll go inside width is what I want. Tab, inside width. And there you go. We can finish that sketch. Then we can extrude it. And if we just start like that, you can see it's doing something weird right now, but we've just got to make sure that we've turned it into a new component. We'll come down and we'll just go -3mm, which is just going to be the thickness of the material. Okay, and you'll see it over here. We'll rename it. And while we're there, we might as well just make a new component, and we'll call this tray assembly. And then we can just get all the parts of our tray. So we'll click the first one, pressing our shift key, and we'll select the last one, and we'll put them all into our tray assembly. There we go. We'll go back to our home view. Now, if we go and, because we've been kind of sort of constructing all over the top of everything, you can actually see that our tray is kind of, you know, half in our box. So what we'll do in the next tutorial is we're going to move the tray, and we're actually going to create a sliding joint so we can actually animate the tray and show it sliding in the correct space.